Okay, a few things we know about having a relative maximum. So we know that to have a relative maximum, let's say this is the first derivative, obviously. First derivative has to equal 0. Let's say that the value is a. To be a maximum, I have to first be increasing, then decreasing. So that means my first derivative has to be positive, then it has to be negative. So that means it has to be positive, then negative. In other words, it has to go from above the x-axis to below the x-axis. So if I'm looking at the graph of the first derivative here, okay, I'm going to erase the extra information about the zeros. We don't need that right now. What we need to find is first it has to come from above, then it has to go below. Well, let's check. This is a 0, this is a 0, this is a 0. Before -2, am I above? No, it's below, so that's not an answer. Cross off the answers that has -2. Let's look at 1. First, I'm above, then I'm above. No, that's not what we want. We want an above and then a below. So for 4, is it first above? Yes. First I'm above. Then I'm below, which is great because that's exactly what we want. So we want C. Okay. Next one, I already drew on it, so I have the graph of the first derivative of the function shown above. Which of the statements is true? So if I'm above the x-axis, I'm increasing. If I'm below the x-axis, I'm decreasing. Okay, so in this picture, I'm increasing from -2 to 0 because I'm positive. So that's increasing. And then I'm decreasing from 0 to 2, so that's decreasing because I'm below. All right, let's see which one helps us out. So A says f is decreasing for -1 to 1. Well, that's not true. Okay, they're trying to confuse you. The graph that we have is the derivative. This is the derivative graph. F is increasing from -2 to 0. Well, didn't we say that? Increasing from -2 to 0? Absolutely, that's right. You can follow through and see that the rest of it is incorrect. For example, f has a local minimum at x equals 0. Well, to have a minimum, we have to have a graph that looks like this, meaning negative or below, and then positive, meaning above. Well, if we look at 0 here, before it is above, after it is below, which is flip-flop of what we want. So that can't be the answer. Then you can go through the options and see that they're not true and that B is indeed the correct answer. Okay, for number 10, they want to find a function that f of x is negative, f prime of x is also negative, and f double prime of x is also negative. Okay, if f of x is negative, that means everything is below the x-axis. If f prime is negative, that means I'm decreasing. If f double prime is negative, that means I'm concave down. Okay, so in a way, I need to find a graph that's below the x-axis, so it's down here. That's decreasing, so it's going down, and it's concave down, meaning it's kind of a frowny face. So I'm looking for a picture that maybe looks like this, because I'm below the x-axis, I'm decreasing, and I'm kind of concave down. So I have to find a picture that looks like this. A is not possible because we want everything to be decreasing. That means, but then this is increasing over here, right? And then decreasing. We don't like that. B is very close to what we want. C, and the problem is it's increasing. It's going up. We don't want an increasing graph. D, the problem is first, it's concave down, then it's concave up. We don't like that. We just want something that's concave down forever. This is the problem is we want f of x below the x-axis. This is above. Okay, so the answer is B. Okay, so f be the function or the derivative given by this. Okay, so we have x squared minus 2 over x. And we want to find where f is decreasing. That means the derivative has to be negative. So we know the derivative is x squared minus 2 over x. We set it equal to 0 first to find the critical points. We also have to consider that the critical points could be the derivative is undefined. The only time that the derivative would be undefined is if we have a 0 in the denominator. So that's one of our critical points. The other one is we have to solve for it. If I distribute x here to get rid of the denominator, I get x to the third equals 2, x equals cube root of 2. So I have two critical points that I'm going to check to see if they truly are critical points. So before 0, let's try -1. If I plug in -1 squared minus 2 over -1, I get 1 minus -2, which is positive. Then if I choose between 0 and square root of 2, cube root of 2, let's try 1. Okay, so if I try 1, I'm going to get 1 squared minus 2 over 1, which is 1 minus 2, which is a negative. Okay. And then afterwards, let's choose 10. If I plug in 10 squared minus 2 over 10, it's going to be a positive. So I'm looking for decreasing, meaning a negative derivative. Well, you can spot it right here, between 0 and cube root of 2. So the answer is between 0 and cube root of 2. All right, number 17. It says, let f be the function given by f of x equals 2x times e to the x. The graph of f is concave down, meaning negative second derivative. Okay? When, So I need to find the second derivative of 2x e to the x. So my function is 2x e to the x. To get the first derivative, I need to split it, 2x e to the x as f and g. Then f prime is 2, g prime is e to the x. I put it together, 2 e to the x plus 2x e to the x. Now I need to get the second derivative. Split it with where the plus is. 2e to the x just becomes 2e to the x. 2x e to the x, well, that was just this original one, so I just bring down the whole derivative here. So it becomes 2e to the x plus 2x e to the x. I can combine 2e to the x plus 2e to the x. It becomes 4e to the x plus 2x e to the x. This is my second derivative. Okay, well, I need to see where it's concave down. So where is it negative? Well, I can set this equal to 0 first and solve. So I can factor out e to the x. I have 4 plus 2x here. E to the x equals 0. 4 plus 2x equals 0. This is never, no exponent of e will make it equal to 0. But here I can solve x will be -2, because if I plug in -2, it becomes 4 minus 4, which is 0. So let's check -2. Okay, let's choose a number before -2. Let's say -5. Let's choose a number after, let's say 0. So if I plug in 0 into my second derivative, either this one or this one, I choose the star. E to the 0, 4 plus 2 times 0 is 1 times 4, which is 4, which is positive. So this area is positive. So we're looking for a negative, okay? So already -2 and above is not an answer. We can cross off all the -2 and above. Okay, if I plug in -5, e to the -5, 4 plus 2 times -5 becomes 1 over e to the 5 times -6, which is a negative number. So this is what we want, everything before -2. So is there everything before -2? Absolutely. That's when it's concave down.
Again, I took the second derivative of the function. I set it equal to 0. I made a number line and checked the before and after to see where the function is concave down. Okay, so I have x here and I have g prime, and it's continuous and has exactly 2 zeros. So it's right here. 1 0 is right here. I'm going to put a star. Another 0 is right here. Okay, that means it's a max or a min. Selected values of g prime are given in a table. If the domain of g is the set of all numbers, then g is decreasing. When g is decreasing, that means the derivative is positive or negative? Exactly. It is negative. Okay, so which of the following intervals is the derivative negative? Well, let's look. Before negative 2 here, my values are positive. Then I hit 0. Then afterwards, my values are negative. Then I hit 0. Then afterwards, my values are positive. So the interval is from negative 2 to 2, where it's negative. Okay, we're decreasing. So from negative 2 to 2. Where is that? Right here. Perfect. Okay, the second derivative of the function f is given by f double prime x. X times x minus a, x minus b squared. The graph of f double prime is shown above. For what values of x does the graph of f have a point of inflection? Okay, so they gave us the second derivative right here. They want the point of inflection. Point of inflection happens when you change from positive to negative or negative to positive. So let's check. Let's check 0. It changes from negative to positive. Great, so 0 is an answer. Awesome. What about A? Well, it changes from positive to negative. Great, we like that. So A is also an answer. What about B? B changes from positive to positive. Nope, that's not an answer. Cross off everything that has B on it. Great. M, what about M? M is not a 0, and this is confusing because we need something that crosses the x-axis that goes from above to below or below to above. M doesn't fit that. So A has to be the answer. Okay, so we're going to pause right here. You can take 2 jumping jacks out of your seat. You can pause and just stretch up or reach for your toes, whichever one you would like to do. And then when you're ready, you can play the next video.